Hi everyone, welcome to this video on object pooling. So as you may know, object pooling is an optimization technique where instead of instantiating and later destroying an object every time we need one, we just instantiate a whole bunch at the beginning called the pool, and we recycle those. So here, for example, I have a pool of 3 missiles, and if I want to now instantiate a 4th one, then we'll just reset the oldest missile in the pool, and that will become the newest one in the pool. So I wrote a quick performance test. My computer could handle regular instantiation and destruction of 100,000 game objects in about 2.5 seconds. So clearly a pooling system isn't strictly necessary for desktop games. Switching over to pool mode, however, the same operation takes only about 40 milliseconds, so you can imagine that it can be a really great ally when developing mobile games. Alright, so to get started, let's create a new C# script. I'm going to call this the pool manager. I'm going to create a new empty game object. Can just call that pool manager as well, perhaps, and just assign the pool manager script to that. Let's open the script up. So we're going to want a method for creating a new pool. So we can say public void create pool. So we want to take in a game object for the prefab that we're loading into our pool, and also an integer for the pool size. So for example, if you have an object like a bullet, you might want to load in a lot of them, because there could be a lot on screen at once. But if it's something like an explosion effect, you could maybe get away with far fewer. So we're going to want to store each of our pools as a queue, so that when we're reusing an object, we can simply take the first one out of the queue, that being the oldest object, and then just add it back onto the end of the queue. So it probably makes most sense to store all of our pool queues in a dictionary so that we can easily find the pool that we're looking for when we get asked to reuse a specific object. So let's say using system.collections.generic, so we get access to all good stuff like dictionaries and queues, and we can say over here dictionary, and for the key we'll use an integer, which is just going to be the instance ID of the prefab. And then we'll say queue of game objects for our actual pool. So we can call this our pool dictionary. Just set that equal to a new dictionary of integers and game object queues. So at the start of this method, let's say int pool key is equal to the instance ID of the prefab we've been given. So that's a unique integer for every game object. And what we want to do then is just make sure that this pool key isn't already in our dictionary, otherwise that will throw errors. So we can say if not pool dictionary dot contains key, pass in the pool key, then we can go ahead with creating the pool. So we'll want to start by actually adding it to the dictionary. So we can say pool dictionary.add. We want to add the pool key as well as a new queue of game objects. So new queue game object. Alright, next we're going to want to instantiate a number of these prefabs as dictated by the pool size. So we'll want to do a little loop for int I equals 0, I less than pool size, I plus plus. So we can say game object, new object, and we'll set this equal to instantiate. We want to instantiate the prefab we've been given, and we want to just make sure that that's instantiated as a game object. And then we don't want that to be visible in the scene yet, so we can just say new object dot set active false. Alright, finally we'll want to add it to our pool, so we can say pool dictionary, and then we can get the correct pool by just passing in the pool key. And then we want to add it to our queue, so we just say queue.enqueue, and we say new object. Alright. So next we'll want a method for actually reusing the objects in our pool, so we can call this reuse object. So we'll take in a game object for the prefab that we're dealing with, and then as if we're instantiating it, it will also take in a vector3 for the position and a quaternion for the rotation. Okay, so we can start off just by getting our pool key once again. So we can say int pool key is equal to prefab.get instance ID. And then we can do a quick check to make sure that our pool dictionary contains such a pool key. So if pool dictionary.contains key, pool key, then we're going to want to get the next object in that pool. So we can just say game object, and call it the object to reuse, is equal to pool dictionary with an index of pool key dot dq to get the first one out of the queue. Then we'll want to add the object back onto the end of the queue so that it can be reused again later. So we'll say pool dictionary pool key dot enqueue and pass in the object that we're reusing. Now, of course, when we talk about destroying a pooled item, we're only actually disabling it so that it becomes invisible in the scene. So what we want to do when we reuse an object, in case it's already been destroyed, we'll want to say object to reuse.setActive true. And then we just want to set its position and rotation to the supplied values. So object to reuse.transform.position is equal to position. And likewise, object to reuse.transform.rotation is equal to rotation. Okay, so now we'll just want a easy way to access these methods from other classes without having to get a reference to the pool manager. So we can do that using the singleton pattern. We can just say static pool manager. We can call this our underscore instance. And then we'll have a little accessor, public static pool manager, and just call this instance without the underscore. So we'll say get. So first we'll want to check if the instance is null. So we can say if underscore instance is equal to null. Then we'll want to find the instance of the pool manager script in the currently active scene, which we can do by saying underscore instance equals find object of type pool manager. All right, and then finally we'll just return the instance. Okay, so I'd like to take a moment to set up a little test scene so that we can look at how to use the pool manager and also what remains to be done. So let's go into Unity and just create a folder, call this test. We can put all the test stuff in there so we can delete it easily once we're done. So we want a C# script for the test manager, and then also another one for the test object. So let's make a little 3D cube. I'll apply the test object script to that, and then we can just make a prefab out of it and delete it from the scene. So all I really want the test object to do is just move forwards. So let's say transform.translate vector3.forward multiplied by time.delta time, and then multiplied by some speed, say 25. All right. And then we'll want to bring our test manager into the scene. So I'll just make a little test game object here, just add that. So we'll want a public game object for our prefab, and then in the start method, we can just create a pool for that prefab by saying pool manager.instance.createPool. So we pass in prefab, and let's say it's got a size of 3. Then in the update method, let's say we instantiate or reuse an object from our pool whenever we press spacebar. So if input.get key down, keycode.space, we'll say pool manager.instance.reuse object prefab, and we can just reset it to a position of vector3.0 and no rotation, so quaternion.identity. So now just add the cube to the prefab slot, and when we press play, we get these 3 deactivated cubes, and each time we press spacebar, we should get one zooting out. And since we've only got a pool size of 3, if we now try to create a 4th one, we'll see the oldest one disappears as we expected. So that works fine. Of course, if the object has got properties that are sort of changing, then those aren't going to be reset. For example, say in our test object we say transform.localScale plus equals vector 3.1 times time.delta time. Let's just make that a little bit faster, say times 3. Okay, so now our objects are growing in size over time, but if we reuse one of them, the size doesn't get reset. So sadly, there's no sort of magic way to just reset the prefab back to how it was at the beginning. So the best we can do is just notify each object that it's being reused, so that it can manually reset everything that it needs to. You can imagine a more practical example, maybe it's like bullet trails or particle effects needing to be reset. So what we'll want to do is create a new script. This is not a test script, and this is our pool object script. And this will have a method, public virtual void on reset, or maybe best as on object reuse. So our test object, for example, should now extend pool object, and it should override that on reuse method. So we can say public override on object reuse, and we can just say transform.localScale is equal to vector 3.1. Now our pool manager, of course, needs to detect if the object that we're reusing extends pool object, and if it does, then we'll want to call the OnObjectReuse method. So let's go into the pool manager script, and I'm just going to make a little class called objectInstance, which is just going to store some information about each of our pool objects. So it should have a reference to the actual game object, so we can call that game object simply, and can have a reference to its transform. And then we'll want to also have a reference to the pool object script attached to it, so pool object script. But since we're not enforcing that every object has a pool object script attached to it, let's also make a little bool called has pool object component. Okay, so this will have a constructor, public object instance. We'll simply take in a game object called object instance, and we can say, okay, game object is equal to the object instance that's been given to us. The transform is equal to game object.transform, and then if, and only if, the game object has the pool object script attached, then we'll say has pool object component is true, and we can set the pool object script equal to gameObject.getComponent pool object. Okay, so instead of our dictionary storing queues of game objects, we're actually going to be storing queues of object instances. So let's just replace that there, and also over here. Then down here, where we're creating our new object, instead of creating a new game object, we'll create a new object instance. So object instance new object is equal to a new object instance, and we'll pass in the game object that we've just instantiated. And we can leave this setActive false out. We're going to actually do that in the object instance constructor. So we'll just say gameObject.setActive false. And then this class is also going to have a public void reuse, which takes in a vector 3 position and a quaternion rotation. And what it'll first do is it'll say if it has the pool object component, then it's going to notify the pool object script. So pool object script dot OnObjectReuse, and then it's going to do all of this stuff over here. We're just going to copy that, or rather cut it, into here. So this will just be GameObject.setActiveTrue, and then transform.position equals position, and transform.rotation equals rotation. So over here where we cut that from, we'll want to say object to reuse, and of course this should now be a object instance instead of a game object. We'll want to say object to reuse dot reuse, and just pass in position and rotation. Okay, so now pool object OnObjectReuse is being called, so our test object should be notified and it should reset its scale. Let's give that a go. Got a little error. So it seems that I accidentally undid my object instance over there, so I'll just paste that in again. And same thing over here really when we're creating the new queue. It shouldn't be a queue of game objects now, it should be a queue of object instances, so just change that. Alright, and now if we press play and create 3 objects, when we reuse the last one, you can see that its size is getting reset. Okay, so our work is basically done. I just want to do a little bit of organization. You can imagine that if, say, our test manager, instead of creating a pool of size 3, was creating a pool of, say, 30, and we had other pools being created elsewhere as well, the scene is going to become quite a mess. So what I'd like to do in the pool manager when we're creating the pool is just to create a little sort of holder object to store all of the game objects under. So let's say game object pool holder is equal to a new game object. Give it a name just based on the prefab name, I guess. So prefab.name plus pool. Okay. And then we can say pool holder dot transform dot parent is equal to this transform, and then we want to set the parent of any objects that we create to that pool holder. So we'll have to create a method in the object instance class. So let's say public void set parent takes in a transform parent, and then we can just say transform dot, oops, that should be a small t, transform dot parent is equal to the parent we've been given. So over here we'll say new object dot set parent and pass in pool holder dot transform. Okay, so now the 30 of those should be stored in a little cube pool over here. Fantastic. So our pool manager script is now complete. One tiny thing I'd like to do maybe with our pool object script is just to create a protected void destroy. So if we wanted to destroy the object, we could call this method instead, and instead of actually destroying the object, we just say GameObject.setActive false. Okay, so that's everything that I had planned for this tutorial. Before I finish though, I'd like to quickly show you how to reset the trail render component, because it hasn't been made very intuitive. So I'm just going to add a trail render effect to the cube, turn the time down to say 0.5, and I'm going to set the pool size of the prefab to just 1. So you can see that when we reuse the object, the trail will get redrawn all the way back to the start, so we need to reset it, but there's no sort of reset method on the trail render component, which there really should be, of course. But there is a little workaround. Say we have a reference to our trail renderer, so let's say trail renderer trail. We'll want to store its time as well, so float trail time. Then in the awake method, we can say trail is equal to get component trail renderer, and the trail time is equal to trail.time. So what we need to do in the OnObjectReuse method is we need to set the trail time to a negative number, so say -1, and then on the next frame we need to reset that time back to its original trail time. So we can have a method called, say, reset trail, and we can say trail.time is equal to trail time, and then over here we can just invoke that method. So invoke reset trail, and we'll want to invoke it after a small amount of time, so say like 0.1, and now that should work. Alright, so that's everything for this tutorial. I hope you found it useful. Goodbye.